So what we're gonna do for this chapter 6, part 2, is we're gonna focus on the trig function. Okay, trig function. So sine of 0 is 0. Sine of pi over 6 is a half. Pi over 4 is root 2 over 2. Root 3 over 2 and root 1. What happens at 2 pi over 3?
Root 3 over 2?
Again, root 3 over 2.
Root 2 over 2?
Root 2 over 2.
Half.
A half. At pi is 0. Okay, stop right there. What's happening there?
Those are all positive?
So 0, it's all positive. Sine is positive from 0 to pi. And what's happening here, it's getting, the value gets bigger and bigger and bigger until it hits the maximum, which is 1. And then it starts to go down at 0. Okay? Now what happens here at 7 pi over 6? Sine is negative, correct? And it's going to be?
Negative half.
Negative a half. Okay. Now, do we understand this piece? Do we understand that piece there? Let me take my unit circle back again. So where's 7 pi over 6? 7 pi over 6 is over here. And then we're looking at the sine, which are the y values. So negative a half. Okay? What about 5 pi over 4? It's going to be negative root 2 over 2. And then this is going to be negative root 3 over 2. And at 3 pi over 2 becomes
Negative 1.
Negative 1. And then 5 pi 3 is going to be negative
3 over 2.
Negative root 3 over 2. Negative root 2 over 2. And that becomes negative a half. And at 2 pi is 0. Okay, what just happened there? What just happened there?
1 round of circle.
That's a 1 round of circle, one whole thing. Okay, so we're talking about the y values. Okay. So from 0, the y values gets bigger and bigger. Okay, the y values is right here. Bigger, and then starts to get shorter, even shorter to 0. And then from here, because it starts to get longer again, but since it's at quadrant 3 and quadrant 4, it's the y values are negative. That's why it's negative and up to negative 1. And it gets shorter and shorter and shorter again, but it's below, so it's negative. And it's back at 0. So what does that mean? Okay, now let's take a look, see if we can graph it. What kind of graph are we talking about in here? What's the shape?
A wave.
A wave. A wave. Yeah. Good. So let's do that. So this one here is going to be, from here to here is pi. And it's cut in how many parts? 1, 2, 3, 4, 5, 6. So each one is pi by 6, right? Now, 2 pi by 6, that's the same thing as 1/3 pi, right? Okay. 1/626 3/6, so that's going to be a half. By half. 3/6, 4/6, so that's going to be 2 pi over 3. And then this is 5 pi over 6, and then this is 6 pi over 6. Okay. This one would be 7 pi over 6. This is 8 pi over 6, but it's 8 pi over 6. So if you would do that, is 4 pi over 3. Okay. It's 8 pi over 6. 8 pi over 6. Now we can reduce that, divide that by 2. So that's 4, 3. That's why it's 4 pi over 3. So, okay? It's just reduced. And then this one here is, okay, 7 pi over 6, 8 pi over 6, 9 pi over 6. Okay, what would be
3 pi over 2.
9 pi over 6 would be
3 pi over 2.
3 pi over 2. 9 pi, 10 pi over 6.
5 pi over 3.
5 pi over 3. Okay. And then 7 pi over 6. And then this is 8 pi over 6. Okay. Now, this is from 0 to 2 pi. So what just happens? Can we imagine it? So 0 is 0. If the angle is 0, sine of 0 is 0. At pi over 6, it's a half. Hmm? 11. Yeah, that's right. Yes, this is 11 pi over 6. 11 pi over 6. Now, do you see pi by 4s in here? Where is pi by 4? I can't see. Oh. It's upside down, plus it's far. Okay, so where's pi by 4? Let's see here. Where's pi by 4? Pi by 4 is in between pi by 6 and pi by 3. Okay, that's okay. We don't have to do that one. Okay, let's do pi by 3. Pi by 3 is root 3 over 2, which is about 0.8 something, right? Yeah, give it a try. Root 3 over 2. .8 something, right? Yeah. 866. Okay. 0.866. Good. So that's probably somewhere up here, right there. I'm just gonna. And then the next one at pi half, that's 1. Okay. We're just gonna do the ones that are easy to graph. Okay. So which one is the next one? At 5 pi over 6 is 1/2, so that's a half right there. And pi is 0. Okay, so what's the shape there? You said it's a wave. Okay, well, what does a wave look like? It kind of goes like this. Okay, it's not, it has to be a smooth curve. Okay, it's not a V, okay, and it's not a parabola, right? Because now let's go over here. At 7 pi over 6, that's going to be -1/2. Okay. Now my next one is a 3 pi by 2. 3 pi by 2 is at -1. Let's keep going. Has to be a smooth curve. And okay, it's not a V. And then 11 pi over 6, that's a half. So it's going to be like this. And then at 2 pi again, it's at 0. So now, you know how you memorized what a parabola looks like, right? This one you're going to memorize what the sine graph looks like. So this is a graph from 0 to 2 pi. What about the negative? What happens here? Where does if you have a negative pi by 6, what would that be? Negative pi by 6. Let's try that again here. Okay. Negative pi by 6 is going pi by 6 this way. What's the y value? What's the sign? Negative half, right? Negative a half. Okay. Let's try another one. This is going to be, I'll type this in, or I'll write this in, negative pi by 6. This is going to be negative 2 pi by 6. And then this is going to be negative 3 pi by 6. If you have a negative 3 pi by 6, where would you be? Okay, let's take a look. This is 0, negative 1 pi by 6, negative 2 pi by 6, negative 3 pi by 6, so that's at negative 1.
Too far.
Oh, did I? Yes, it is too far. Let's see. Why is that weird? Is it weird? Negative 1 right there. Yeah? Okay, so this is what the graph looks like, and this is what you're going to memorize, what the graph looks like, starting from 0 to 1, back to 0, down to negative 1, back to 0. Okay, so this is what the sine graph looks like. Now we're gonna take a look at this and say, what's the maximum value? What's the most maximum value that you can have? 1. Positive 1. What's the minimum value? Negative 1. Now this is something that's new, okay? The word amplitude. If you are taking physics, you probably heard of the word amplitude. What's the amplitude?
The measurement from in between the highest crest to the lowest trough.
Okay, now some people is saying some physics words, some physics terminology, and if you're not taking physics, it's okay. It's just, and I think some of you are, right? So in physics, this is, you talk about waves, right? There's like sound waves, there's light waves, there are microwaves, X-ray, gamma rays, and it's basically all of a wave. So this is what a wave looks like, right? And that's, now, in physics, okay, the maximum is called a crest. crest. Now, we're not going to use the word crest in math. We just call it maximum. Okay? Good? Okay. Now, this one here is called the minimum. And in physics, there's a term for a minimum, which is, it starts with a T, trough. I don't even know if I spelled that right. I did? Oh, okay. Trough. Right. Yeah. So, amplitude. The word amplitude in physics is the same amplitude in math. And the amplitude is basically, oh, okay, well, you have this middle part is called the median line. Median means the middle line, right? It's somewhere that falls in between a maximum and minimum. So amplitude is from median line to the maximum. So this is amplitude. You call it A, or it's A in physics, amplitude in physics. What's the other amplitude?
The trough.
It's from middle to the minimum. That's also an A. So what's the amplitude here?
The full, like 1.
1. Amplitude is 1.
Plus or minus?
From here to there. So amplitude, I'm just gonna put here. Okay, this is called the A amplitude. Yeah, amplitude. Yeah, sure. So the amplitude is from middle to the maximum or middle to the minimum. And in this case, it's 1 unit. Okay? Now, period. What's a period?
Probably 1 full circle if we're counting, if we're doing 1 full lambda.
Okay. Amplitude is, amplitude is there. The period is how long will it take to go from, median to the median to the next wave. How long does it take to complete one wave? Now from here to here, is the wave complete? No, that's like half a wave, right? So, what's a full wave? So from here, maximum to median to minimum. That's 1 full wave. Like, do a wave. Like, go to Jets fan or any sports game, you do the wave, right? You don't go like that. You don't go like this. They actually go down. Right? They do the wave. And so this is 1 full wave. How long does it take to 1 full wave? So in this case, how long is it? 2 pi.
2 pi seconds?
Oh yeah, no, we're not going to do units right now. Okay. What about the y-intercept? What's
0?
the y-intercept? 0. Okay. In this case, when we talked about y-intercept is where the x is 0. Here, this is the only time the x is 0. Right? When x is 0, what is the sign of 0? 0. Now, what about, oh, this is a tricky one. X-intercept. Psst. Okay. How many x-intercepts do you see? Just by looking at this.
Won't it hit infinity pi if it just keeps going?
Yeah, it's gonna keep going. Okay, so it's gonna go from, okay, x-intercept is here. This is our x-axis, right? Our x-intercept is there at 0. Where else? At pi, right? So it's right there. Where else?
2 pi.
At 2 pi.
3 pi.
Okay. At 3 pi, 4 pi. Well, those are... Okay, well, what about if we go the other way?
Negative pi.
Yeah. If we were to continually graph this thing, it's gonna hit at negative pi, negative 2 pi, negative 3 pi, and so on. So in this case, just what we see in here, there's gonna be infinitely many x-intercepts in here, right? So we can say this is gonna be 0, pi, 2 pi, dot, 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 and then comma. In this way, it's going to be negative, dot, dot, negative pi. Okay, that's good. Later on, we can write down the formula for this so that we can say there's going to be infinitely many, right? So, or we can say 0 plus pi times k. And what do you think the k is?
Any positive or negative integers.
Any integers, right? Any integers where k is an element of an integer, right? So you start at 0 radian, okay, because we're talking about radians here. 0, and every time you add a pi to it, so pi, you're going to see that. If you add 2 pi, you're going to see that. If you add 3 pi, you're going to have that. Now if you go negative pi, then you're going to have a negative pi, negative 2 pi. So this one is called a general form. Okay, because there's going to be lots and lots of x-intercepts. If there's infinitely many, we can't list them, but we can generally figure out where they're at. Okay? Now let's take a look at this. What's the domain?
Was this like pi infinity? Negative pi infinity?
So that'd be negative. Okay, maybe I should read this because it says here we will sketch the domain from 0 to 2 pi. Yeah, we actually did not sketch from 0 to 2 pi, we actually sketched beyond. So if we stick to this, what's the domain?
0 to 2 pi?
0 to 2 pi. 0 to 2 pi. Okay. Now, is that going to be 0 to 2 pi forever? Or is it just going to be 0 to 2 pi?
Right now?
Right now it is, but it could be continuing on.
Do we have to put dots to stop it?
Hmm?
Do we have to put dots to stop it in these types of graphs?
Yeah, we can put a stop there, a dot there, and then a dot there, but we didn't, so, okay. What about the range? Range are the possible y values. So what's a possible y values?
Negative 1.
-1 to +1. Okay, so this is called interval notation when you have the beginning to end, minimum to maximum. Now, what about the set notation? What would the set notation look like? Y is going to be greater than or equal to -1, but less than or equal to 1. So if you read some texts, some textbooks, it could be written this way. And if you read another textbook or you watch another YouTube video, then you might see this. What about the domain for this?
X is greater than or equal to 0,
Mm-hmm.
and less than or equal to 2.
Exactly. And brace, brace. Is that okay? Is that good? So, you've memorized that the graph of the sine of theta or sine of x is going to be starting from 0, reach a maximum, minimum, 0. And that's one whole period. Yeah.
And the graph y, we are asking the pi over 4.
Oh, where is the pi over 4? Pi over 4, let's see here. Pi over 4, where's my other booklet?
For the quarter of a
Yeah,
pi.
so a quarter, okay. So if this is a pi, right? This is half a pi, a quarter of a pi. So if this is half, a quarter would be somewhere in here. This is where the pi over 4 is. Can you see it's between pi over 6 and then 1 pi over 3, right? So that's where pi over 4 is. Now I'll show you where that is in here. Can you see here? Pi over 6 and pi over 3. That's where pi over 4 is, in the middle of these two angles. So this is where the pi over 4 is. If we want to do that, yeah, let's go ahead and put that in. And pi over 4, the sine of that is root 2 over 2. And what's root 2 over 2? Okay, root 2 divided by 2 is 0.707. So that's going to be somewhere like right there. Is that okay? Yeah. So for me, if I were to do this, okay, I'm going to look at the important points. So what's my most important points? The ones that are easy to graph. Actually, I'm going to pick the best 5. If I ask you, pick the best 5 points that you can graph so that you can do the graph of the sine function. What would be the best 5? So you're going to pick the best 5. These are your best 5. You're going to pick this, which is there. Where else? Huh? Pi over 2. What's the other one? Pi at 0. What's the other one? 3 pi over 2. And 2 pi. So you don't have to normally graph every single point, but if you memorize these p's, and I'm pretty sure you have, right? So where is this? 0, 0. That's this one. Pi over 2. That's where the maximum is. Pi, if the angle is pi, sine of pi is 0. 3 pi halves is -1. And then 2 pi is 0. So once you have those, only 5 points that you need, and then the rest will be just that. Okay? Good? Now, are there any questions about these? I'm going to show you a video later of some places where you can actually see where this sine function happens, where you see it really. Okay, now, no questions? Now, this one here is a cosine function, so y is equals to cos of x, and we're only going to be interested from 0 to 2 pi. So 0 to 2 pi. Okay. Now, if we pull out our unit circle again, the cos are the, which one? The x coordinate on our circle, on our unit circle. So here, 0 radian, what's the cos of 0 is? 1. Yeah. What's the cos of pi by 6? Root 3 over 2. What's the cos of pi over 4? Root 2 over 2. 1/2. At pi half, 0. And then negative 1/2. Are you okay with this? Yeah? Okay. Because now if you're at 2/3 pi, you're at negative 1/2. Right there. Okay, 3 pi over 4 is negative root 2 over 2. 5 by 6 is negative root 3 over 2. And then at pi is negative 1. And 7 pi by 6 is still negative root 3 over 2. Negative root 2 over 2. Negative 1/2. And then root 3 over 2 is 0. Yeah, are you still okay? This is root 3 over 2. We're talking about the x because that's what cos. 5 pi 3 is going to be 1/2. Positive 1/2 because you're in quadrant 4. Cos is positive in quadrant 4. 7 pi over 4 is root 2 over 2. 11 pi over 6 is going to be root 3 over 2, and then back to 1. Okay. So, we can go ahead and enter those things, but if I ask you pick the 5 best points, what would be the best 5 points that you can? 0, yeah. Pi by 2, pi, 3 pi 2, and then 2 pi. Okay?
So always that.
Yeah, and then the rest will follow. We could do all those just to plot them and see where they're at, but they're going to fall into places once we graph those 5 key points. Okay. So if x is 0, cos of 0 is 1. So right up there. Where is pi half? Huh? In the middle of? Between 0 and pi, right? Between 0 and pi. So that's going to be at 0 right there. And then pi is negative 1. And then 3 pi halves is right there. And then 2 pi is up there. Okay, what does a graph look like? We didn't graph all of them. It still looks like a wave, but it's kind of going like this. And of course, this takes a lot of practice to kind of, and you'll get it. So make sure there's still some kind of a curve. It's not quite a parabola. It's not a V. Okay, so make sure there's like a little bit of a curve as you go.
Could we also just lay out more points?
Yeah, you could do that. Yeah. Oh, actually, we could do here. Pi by 3. That would be a half. It's probably there. That's a good point there. So now that we know this, I'm going to put this back in here. So for sine earlier, it was the vertical distance from the x-axis. What about the cosine? Cosine is the distance horizontally. That's the distance. So if you're here from 0, 0, 0, 1, the distance is 1. As you're moving around the circle, you're actually getting along the x, you're getting closer and closer and closer to the y-axis. Okay, so that's what's happening. Okay, now let's take a look. Maximum and minimum value. Characteristics. What's a maximum value?
1.
Maximum, that's the highest, is 1, positive 1. What's a minimum? Negative 1. Amplitude, 1. Yes? Yeah. An amplitude is from median line to the maximum, or median line to the minimum.
So we put plus in. Is it always going to be positive, or will we put
Amplitude is plus.
always plus?
Yeah. And then we'll see y would be negative, and I'll tie it into something that we've already done before. Period is how long does it take to create the one full revolution? That'd be 2 pi. Y-intercept is 1. X-intercepts are
0 plus pi halves, okay?
yeah, okay, so in this case, okay, where are the x-intercepts? The x-intercepts are pi half. This one here is 3 pi halves, and so on. Okay, so x-intercepts are, in this case, it's pi half and 3 pi half. Okay, what's a domain? Zero to 2 pi, or we can say x is greater than or equal to 0, but less than or equal to 2 pi. And what's the range?
1, negative 1 to 1.
Negative 1 to 1, or we can say y is greater than or equal to negative 1, but less than or equal to 1. Phrase. Okay, how do you feel about that one? Okay, now can you see the difference between the two, the sine and the cosine?
Yeah, the cosines are big.
The cosine starts at maximum, minimum to maximum again, right? And sine starts at 0, maximum, minimum, 0. So now I gotta show you, where do we see this thing? And I know some people are doing physics stuff, and that's okay. We talk about that in physics a lot, right? But I'm gonna show you where you could see this in real life. Good thing I actually brought this in. Now you're just looking at this circle piece here. And what's happening here is, if I go like this, happening? Yeah, you see rotation. Okay, I don't want to go like that way. When this is a minimum, middle, maximum, middle, minimum, right? Middle, max, middle, min, middle, okay. You get what I mean, right? Now, here's the other thing. Grandfather clocks. What does a it doesn't have to be always, we're always thinking like circular function, wave, always have to do with anything going around. Well, that's one going around, right? But this is, here, this is not going around. Explain this.
Momentum.
Okay, maximum, minimum, maximum, minimum. Somewhere here would be middle. Maximum, minimum, maximum. Is it going around? No, but it's still
A wave.
It's still a wave when you graph it, right? The period is the time it takes for this pendulum to swing back and forth. That's what pendulum is. Pendulum, and you'll probably learn it in physics, this is the time it takes to swing from one complete. Okay? That's square one. Okay.
What's the frequency? Do we deal with frequency?
In somewhat, yes. Yeah, in somewhat, yes. Okay, I'll show you another one. And normally I don't show my, usually my personal life. My personal life is my personal life sometimes, but I can't help but to show personal stuff. Okay, here. Ah, no, this is my kid. What's happening there? Oh, this is slow motion. This is a great part.
So you're thinking math when you're at the park?
Yeah, I'm thinking about math when I'm at the park. Oh, this is my daughter, right? Can we write? I suppose if I do some measurements with her height and the time it takes for her to swing one from the maximum would be the farthest away that she is from me. The minimum would be probably the one. Yeah, almost she kicked me in the face right there, right? Can you see maximum farthest away, minimum closest, and then when she's somewhere vertically right there, that's a median. That's where the middle is. Yeah, that's where she's in the middle. Minimum, maximum, oh no, median. See? Hey, we can't, no, you're sick of that after. Like, you can only see it a few times. I like to bring things in, like real life stuff. Because otherwise, you look at this is meaningless to me. Why am I doing this? Sometime in June, you're gonna go to Red River X and there's Ferris wheel. Okay? But it's not just all about that. Okay? So, here. Characteristics of sine function. Probably gonna go up to this part. And yeah, actually we'll take a break and then we'll come back to this. Okay? So I'll kind of give you a little bit of a break.
Are we going to deal with refraction at all in these waves? Or are they just going to be constant?
Oh yeah, we will do some fractions. We will
No, refraction. Like